In today's talk, I'm going to briefly review how we can use technologies to fight AI synthesized fake media. So recent development in artificial intelligence have given us a lot of new ways of manipulating and synthesizing fake media. So here I just give you some examples, notable examples of fake media. For instance, we have this highly realistic, convincingly realistic human faces that are generated by deep neural networks known as generative adversary networks, or GANs. They are very difficult to tell apart from real human faces. As you see, the neural networks capture the fine details of human faces really well. We also have this kind of face swapping videos that we call deepfakes. Here I'm showing you an example of deepfake video. The one on the left is a real video, and the one on the right, as you can see, the face of the subject has been replaced with another person's face while keeping the same facial expression. This is essentially generated by a deep neural network automatically. And it can be done very easily these days because the technology has advanced in the past few years. Same kind of situation also apply to audios. So as you can see here, you can hear here, the first sample is a real human speech. The second one is synthesized from the first one with a different person's voice, but also keeping the same tone and the content. So this AI synthesized media has become very easy to generate. Let me give you some idea how they are actually produced in practice. So let's take the simple, maybe the most popular example of those face swapping videos, or sometimes known as deepfakes. So always need to start is an original video of someone whose face we want to replace. And then the first step is to run a computer vision algorithm to automatically extracting the face out and then align the face. So we've got all the face regions extracted from the original video frames. These extracted faces is going to be fed into a neural network model. Here we just call it a deepfake model. And as a result, the deepfake model creates another person's face, but with the same facial expression as the input. Now let's look into a little bit the under the hood details of this deepfake neural network model. It is actually composed by a pair of neural networks. One is known as the encoder, the other is known as the decoder. The encoder's task is to separate the facial expression of the input from the identity of that subject. And all the essential facial expressions are represented in this vector known as the code. The code is then fed into the decoder, which combines the target's identity with the input's facial expression and create us this video, okay? And each of decoder and encoder is actually a mathematical computational model known as convolutional neural network, okay? It is formed by a set of artificial neurons, which are computing units simulating the functionality of a biological neuron, and organized in the form of in different layers in the hierarchical model. Each of this artificial neuron is just a mathematical function, as I mentioned, trying to simulate the basic functionality of a biological neuron cell. Now, once we run through the deepfake synthesis model and getting the synthesized faces, we can put them back into, we can mask out the unused area, just leaving the facial part, and then paste it back into the original video. Now we got a seamless face swapping video created from this pair of neural networks. As you can see, the whole procedure can be automated and with the least of human intervention. Now, what I just mentioned, what I just talked to you, introduced to you, is the process of synthesizing face swapping videos. But to be able to do that, we first need to get the pair of neural networks, as I talk about the decoders and encoders. And to obtain that pair of neural networks, we need another process, which we call training. So training starts with sets of face images of both subjects we want to swap face with, okay? And we just run through all this face images through the pair of encoder, through a common encoder and a pair of decoders. The encoder is shared between the two subjects, while the decoder, the decoders are specific to individual subjects. And the way of training is very simple. We start with some initial parameters of the two neural networks. We run through the faces of one subject and go through the encoder, creating the code, and go through the decoder, we can generate the target faces. And then we just compare the reconstructed faces from the original ones and trying to minimize that error. We are going to do the same for the second subject, and we're going to repeat this process many times across the two different subjects. Now, this is the part where we need a lot of computation power. So that's why we need powerful hardware to support this. And the hardware, specific hardware that is usually used is this model called GPU, or graphics processing units. Now, the graphical processing units, you can see, you can understand as highly paralleled computers with many processing units, okay? With the GPU, the computer can run the training process much faster. Now, what I'm showing you here is a process of the training. At the very beginning, the model is very crude. So it creates a face that is very blurry without any specific features. Well, as the training progresses, you can see that the quality of the synthesized face is getting better and better. And actually, to be able to show this training process in real time, I actually play this video with 5,000 times of its original speed. But the training these days is also, you can do this in a couple of days. So indeed, it's not the biggest problem. So why are AI synthesized fake media harmful? There are several reasons for that. First of all, technology has advanced to the extent that they're very easy to make. Just go on open source code sharing repositories like GitHub and search for face swapping deepfakes. You can get quite a few wrap up code, ready to be used and free to the general public that you can use to create this kind of fake media. And then if you can buy a commodity computer, which doesn't cost more than $5,000 these days, and go on internet, get a lot of training data of the person whose face you want to replace with. Then with some patience, with some basic skills of machine learning and coding, almost everyone can start making fake media. So the technology definitely has democratized the creation of AI synthesized media. The AI synthesized media actually cause real damages. And there are a lot of speculations about fake media can interfere with our election, interfere with politics, or causing real financial damages, AI synthesized voices, using AI synthesized voices. But I think at a very personal level, AI synthesized media can also cause personal trauma, like the recent cases report coverage of this phenomenon known as reverse pornography. So I think this is a scenario, this is a issue that we have to take seriously and understand thoroughly. I think at a very fundamental level, the biggest problem of this kind of AI synthesized media is they erode our trust to the online media in the information. So because the existence of this AI synthesized fake media, it is very hard to convince anyone to trust what they see or hear or read from the internet. And that is, I think, in the long run, the biggest concern we should have about AI synthesized media. Okay. Now, this being a serious problem, so what can we do to control the damage of AI synthesized media? Well, the most direct solution to AI synthesized media is to detect them. Once they show up online, we have technology, we have algorithms that can identify them and expose them and compare them to the real media. There are several different ways we can do this, and I will give a quick overview of how using technology, or sometimes just using a sharp eye, to be able to tell the difference between real media and fake media. Okay, so the first kind of cues you can look for fake media are just simple biological, physiological characteristics that usually are not possessed in the AI synthesized media. So one of our early works of detecting this face swapping videos is based on the very simple fact that the faces in those videos do not blink very naturally. So I'm showing you here 4 examples of early generations of deepfake videos. And you may see that they do not, the persons in the videos do not blink, okay? And that can be used, that unnatural blinking, unnatural head movement could become an important cue to tell that they are generated by algorithms. We also have a recent work to detect GAN-generated images, based on the fact that those GAN images do not respect the ratios, the aspects of real human faces. So they may generate human faces with perfect details at the hair and skin, but the general arrangement and the configuration of the facial parts like eyes and nose are unnatural, as the 2 examples we shown here. Okay. One very recent work we have that's shown to be effective detecting GAN synthesized images is using the specular reflections in the eyes. Okay, so if we look at the real photograph, high resolution portrait photograph, the subject is looking into the camera, and we expect that both eyes see the same thing. So the reflection from the 2 eyes will have similar patterns. On the other hand, the GAN synthesized images looks very natural, but when the eyes are synthesized by the neural network model, they may actually come from different source training data, and they usually do not have that consistency. So if we compare the specular reflection highlights in the 2 eyes, we see that real faces of real people are very consistent. Well, whereas this is not the case for GAN synthesized faces. We developed an algorithm, automatic algorithm, and a tool that we can actually compare the consistency of the speculative reflections of 2 eyes, and turns out this is a quite effective approach to detect GAN synthesized faces. Another type of cues we can use to spot AI synthesized fakes are from physics. So take take in consideration detecting face swapping videos. Now we know that for a face swapping video, the face is actually spliced onto the original person's face. Now we know that by physics, face is part of the head, and when head is moving in three-dimensional space, face move along with it. But if we have a fake video where the face is generated not by respecting this 3D motion in the physical world, but is spliced on by a 2D nonlinear transform, we'll see those discrepancies, especially when the subjects are looking away from the camera, which means they're not looking directly into the camera, but looking sideways. That is when the 2D transform, putting the synthesized face on the 3D, on the target's head, will have inconsistencies. So in computer vision algorithm, we have a computer vision algorithm where we can estimate based on the input face where the face is pointing to in three-dimensional space. All we need to do in this case is compare where the head is pointing to using the part of face, the central part of the face, and compare that from the estimation using the whole head. Now, if this is a real person, as I explained, we expect the two orientation to be very close to each other. On the other hand, for fake video, we expect to see a large discrepancy. And indeed, we see that. So this is, again, this physical inconsistency is a very useful cue for detecting AI synthesized fake media. The last category of detection method is using signal cues. Now, unlike the physiological and the physical cues I talked about earlier, these are less intuitive and probably very difficult to pick up by visual inspections. Nevertheless, they are rooted deeply into the generation process of the AI synthesized fake media. So just again, give another example. We use signal cues again to detect face swapping videos. And the key to understand this is that when we use the deepfake model to generate a synthesized face, the face usually has a fixed size. This is limited by the design of the neural network and the limits on the computational resources. So what happened is the generated face need to be stretched, rotated, and then pasted back into the original video frame. And of course, we need to take care of the maker needs to take care of the boundaries of the face splicing. And all these operations actually leave subtle signal level artifacts that we can use to detect them. So we look for the boundaries where faces are spliced into the original frame. And we design another neural network specifically targeting those artifacts. It turns out that this, again, is a very effective method to detect fake videos. Okay. We also take a similar path for detecting AI-generated voices. Now, we have quite a few AI models on the market that we can use to synthesize realistic human voices. Our analysis take all the signals in their Fourier domain, and we use a technique called the bispectral analysis and convert all these different kind of audio signals into something we call bispectrum bispectrograms. Now, in these bispectrograms, without going into any of the technical details, you can see that all these different kind of audio signals have very different characteristics. In particular, the human voices, the real human voices, are very different from the other type of synthesized voices in this bispectral analysis, bispectrogram. Why is that? Well, there is a simple reason for that. When our videos, when we make a sound and somebody heard our sound in a conversation, the sound starting from the mouth of the speaker and will go into the ear of the listener. But the sound, or a microphone, but the sound doesn't reach the destination with one path. Usually, within an environment, the sound actually bouncing off from the ceiling and the wall and eventually being picked up by the listener's ear or by the microphone. In other words, the sound waves coming to the receiving device from different paths with different lengths. And these different lengths corresponding to different arriving time of the same sound signal. And that varying time is reflected as a phase difference. Now, an AI synthesized sound, on the other hand, come out of a deterministic algorithm, and it doesn't have these subtle phase differences. So the bispectrogram we used in the previous slide is just a mathematical mechanism to capture this subtle phase differences in the sounds. And then we can use it to compare with different, AI, the real human voices and AI synthesized voices. Now, we will apply this using the bispectral analysis as a feature. It can be used to very reliably differentiate between real human voices, which is shown by this pale green oval region, and other type of AI synthesized sounds. Okay. So my group is very actively involved in the detection and prevention of AI synthesized fake media. We actually create a large scale face swapping video data set for use of research community. But this is also important to be able to, so the researchers can use this data set to train their model and evaluate the effectiveness of their models. More importantly, we're also providing a new platform, which we call Deepfake-O-Meter. This platform is an open source platform that takes open source deepfake AI synthesized media detection algorithms, integrate them into the same platform, and provide to the end user as a free service. So everyone who's interested in the authenticity of one piece of video can use this service, upload the video or the URL to the video here, choose from a set of state-of-the-art detection algorithms, and wait for the server to create the analysis result and send back the result as a link to an online folder. Okay. So we hope that by providing this service and data set, we can improve the state of art for the research of AI synthesized media detection, as well as providing tools, convenient tools to the hands of online users. Now, the future of AI synthesized media is going to be a continued development. We have, as a matter of this time, a lot of research are being, a lot of methods are being studied to further improve the quality of AI synthesized fake media. Okay, so we talk about face swapping videos that has been improved to whole head synthesis, and it's called a head puppetry. So basically, you can have a target, you can have a source person that can drive the motion of the target and creating very similar facial experiment and also head movement. We also have full body synthesis. This time, not only the upper body, the face, the head, and the shoulder are synthesized. The whole body can be synthesized. So this is a recent work from a group of UC Berkeley. Okay. Also, it is possible to combine audio synthesis with video synthesis together. As in this case, this is a Chinese company creating an AI anchor who can speak and talk, who can talk and show as image online. Okay. And also, we'll talk about human faces. The GAN-generated images and videos are now extending to more general type of images. So like this, all these images are generated by a model known as GAN, and this you can see it is capable of generating highly realistic landscape photographs also. All right, now I've talked about detections, but as I just mentioned, the making of AI synthesized fake media will also improve quite rapidly in the recent years. So what should we do, right? The detection, of course, protects certain measure of protection to us, but it is always passive, meaning that it is only applicable when a fake media when a piece of fake media emerges online. And sometimes by the time we can analyze its authenticity, the damage may have been caused. So what we should do, especially from the technical side of combating AI synthesized fake media, is to continue to develop more effective detection algorithms, but also turn the table on the foundry makers, so that we can be more proactive and make the creation of AI synthesized media more difficult. So some of the recent work in my group already go in that direction. One idea we have recently explored is polluting the training data to disrupt the model training for generating AI fake media. So we know that we have seen the example in face swapping videos. To be able to create high quality face swapping videos, we need a lot of training data. Now, where do this training data come from? The foundry makers actually go on internet and harvesting our personal imagery, photos, videos, and the audio recordings, and use them as training data for free. So what we're trying to do here is imbibe some, we call it pollute the data with some invisible patterns, so that these images or videos, when a human viewer look at them, will not see any difference or visible artifacts. Well, but if they are used by those training algorithms for the models, especially the first steps of those training algorithms usually need to detect faces or estimating facial landmarks. Now, with this polluted data set, on the other hand, they are not able to locate faces exactly, or they will not be able to detect facial landmarks correctly. Now, this will slow down the generation process because they have to find alternative ways. Either they have to run actual cleaning procedure on the data, or they have to manually locate faces and identify those facial landmarks. So this will increase the time, effort, and cost of generation of AI synthesized media, and we hope this will slow down the trend. The other possible way we're now exploring is also mark the data so that fake media become traceable. So this is an idea almost like we radioactively mark the training data and let it go through the model training process. And if somebody use this marked data to train a generation model, the generated media out of this model will have traces of this kind of marks. Then we can say more safely and with higher reliability that this particular image, audio, or video actually is generated by an algorithm and trained using the data set. So all these measures, I think, will complement with detection methodology, detection methods, and will form a more comprehensive solution to the problem of AI synthesized fake media. Now, what else can be done? Especially now, technology is only part of the solution to this complicated social technical problem. I believe the control of AI synthesized fake media requires effort from all walks of life. Particularly, the government need to come up with better policies to guide the use of AI synthesized media. And government funding agencies like DARPA already invest in the research of detection and other countermeasures for AI synthesized media. Big platform companies like Google, Facebook, and Twitter also can play a very important role in the combat with AI synthesized fake media. Now, all these companies, as the first responders to fake media, need to set up certain first line of defense and filter out those fake medias so to protect the end users of these platforms. I think public media also are very important in this combat. With the comprehensive coverage of this phenomenon and education to the user, this will help to improve the user awareness, the awareness of the general public about this problem. So we can be more prepared for this kind of AI synthesized fake media. Okay. Last but not least, I think every online user also has a role in this battle against AI synthesized fake media. We all need to take our due vigilance and to be able to limit the damage, potential damage of fake media from spreading by just checking the authenticity of the media, be more careful about the sources and origins, and then refrain the impulse from hitting the retweet button as we see something interesting and exciting. Okay, in summary, I think we now reach a point at a time where we have powerful AI algorithms that can help us easily generating AI synthesized media. And this AI and this fake media are causing real damages. There are forensic techniques that can be used to detect and obstruct the AI synthesized media generation. However, there is a competition between the making of deepfakes and the countermeasures. And I believe there is no clear winner in the next few years, and the two sides will keep competing with each other for the coming years. That makes it even more important for us to invest more resources and attention and give more attention to this line of important works. Finally, fighting AI synthesized fake media is a community effort. It involves academia researchers, all social platforms, government agencies, medias, and online users. But I am convinced that with the effort from everyone, we can have this problem under control in the coming years, in the near future. Thank you very much for your attention.